Okay, thank you, Robert. I'm Alan Johnston, KU2Y. I'm ANSAP's Vice President for Educational Relations. I'm also an associate teaching professor at Villanova University in their electrical and computer engineering department. So I'm going to talk today about our CubeSat simulator program. Uh, Talk about what it is. I'm also going to share some results of a survey that we did of builders and users of the CubeSat simulator. I'll talk about what the current hardware and software is all about. We currently have an active beta program right now. I'll do a short demo, and then I'll talk about how you can get involved and also take any questions. So I want to start by thanking the team that has put this together. Lots of people have been involved over the past few years in this CubeSat simulator program. I've got the people working on hardware, working on educational materials for instructors and demonstrators, our beta builders who provide detailed feedback on the instructions and the documentation. And also thanks to all the students that have used the simulator, built the simulator in classrooms from high school to college. So what is the CubeSat simulator? It is basically our core outreach program here at AMSAT. And the idea is to give you a CubeSat in the classroom or a CubeSat in your hand. And that way you can demonstrate lots of things with radio, with space, and also just general STEM. And it's targeted to a bunch of different groups: college, university, high school students, the amateur radio community, also to STEM programs. You can teach a lot with sensors and the like. And we're also targeting outreach to sort of non-traditional groups, such as makers, people that like 3D printing, people that like printing and soldering and constructing things. And we've had some success with that. So the CubeSat simulator, it looks like a 1U CubeSat, and it's basically fully functional. It has the basic capabilities of a CubeSat that goes to space, but it's not designed to go to space. The hardware and software instead is optimized for lowest cost in building it and also ease of construction, since a lot of the people putting it together are students, people who are not experienced solderers and the like. But it has working solar panels, rechargeable batteries, and it transmits real radio telemetry in the UHF band. It's a custom 3-board stack, and it has a Raspberry Pi Zero, which runs the C code and the Python code. And it also includes a Raspberry Pi Pico microcontroller, and that talks to a number of different sensors that measure things like voltage, current, temperature, pressure, humidity, and also a 3-axis gyro accelerometer as well. And the real telemetry that it transmits, you can set up a ground station to decode it, and you use the same software that you use for real satellites. And in fact, many people have used the CubeSat simulator to basically get their ground station going, test it out, where you don't have the pressure of a 10-minute satellite pass with the next one coming 12 hours later. You can do a lot of fine tuning while it's all set up here. And we have a Raspberry Pi ground station, which is basically a complete turnkey solution. We program all the software onto a micro SD card. And if you buy a Raspberry Pi 4, an RTL SDR radio dongle, and you just plug the SD card in, and it boots up basically with all the software you need. And there are scripts that allow you to switch between the various modes. Because if any of you have ever used SDR software before, you know that it never plays well with other software. You get one thing working and it breaks your previous application. So the Pi ground station, it's all been tested so that you can seamlessly switch between all the different modes for doing demos and the like. So how many of you have seen a CubeSat simulator or seen me demo it here at Hamvention or Symposium? Some of you? Okay, good. Good, a good number of you. How many of you have actually built a CubeSat simulator? Okay, a few of you. Okay, great. So we've been, this program has been going for over 3 years now, and there's a few hundred of these CubeSat simulators that have been built by people. So we actually initiated a survey. We reached out to as many of those folks as we could find to just get their feedback on the program. And we especially did it because we are involved in a beta rollout of new hardware and software to make sure that we were fixing the things that needed fixing and adding the improvements that needed. So I'll just share a couple of things about the survey that we did. And by the way, if you did build one or used one and I haven't contacted you, please get in touch with me and I'll send you the survey link. So we had 59 responses of people that have built or used the CubeSat simulator. And overall, the feedback was really good. It was actually much better than I thought. One of the ones that I really liked was we asked the question, how would you rate the CubeSat simulator as a learning tool? And we got a ranking of 9 out of 10 for that, which I was pretty happy with. Also, we got feedback on areas that need improvement, things that could be fixed. And it turns out we've actually fixed about 60% of those with the new beta design as well. So it's very encouraging from that perspective. The one result that did surprise me a little bit was we asked the question about the ground station. What do you use with your CubeSat simulator? And not surprisingly, the Raspberry Pi ground station was most popular at 40%, but a third of all respondents said they used their own PC or their own Mac to do it. And that was higher than I expected. The remaining ones, some people used their radio station and the like, and others just didn't use any. They just listened to the signals, basically. So anyway, so one of the changes we're going to make based on this survey is to provide better support for people who install their own software. It's a little bit tricky. It's a little bit time involved in doing that, but it looks like people are interested in doing that. So we're going to provide more support for that. I still encourage you to use the Raspberry Pi ground station solution because that really does work the best, and will give you instant feedback on your simulator once it's built. Okay, so I mentioned that we're in a beta program right now. So if you've seen the CubeSat sim or built it in the past, it's been those white PCBs there. The new beta version is the blue ones, and it has a number of new features. But one of the things we just needed to do was to update things. Since COVID, various parts have been hard to find, and actually the major feedback that we got from the previous builders was that finding parts was difficult. And so we updated the design to make that much easier. And now you can actually get all of the parts either on DigiKey or Amazon. So you don't have to go to a number of different suppliers, and you don't need the experience of ordering from AliExpress if you've never had that enjoyment before. It's kind of fun to do, but a lot of people would like to avoid that. So. But in addition to just updating the design and streamlining some things, we also added a new FM transceiver module, and that provides better stability. It also provides the opportunity to modify the board to fly it as a balloon payload. Because if you get rid of the built-in attenuator, you have a 500 milliwatt transmitter, which is quite sufficient for a balloon payload. And we've successfully flown this payload a couple of times. In addition, the receiver capability allows us to do some basic command and control, and that's what I'm going to try to demo in a little bit here. And another thing, we updated the microcontroller to a Raspberry Pi Pico, which is a much more modern microcontroller. And we also made it easier to add new sensors, which was something that came out in the survey. And in particular, the SparkFun has this quick connector, which is basically just a little standardized connector for daisy chaining I2C sensors. So you can hook them up without actually soldering. And they have a whole suite of these low-cost sensors. So we actually added a quick connector to the CubeSat Sim, so you can add additional sensors without doing any soldering. You just plug them in. And we also standardized the way you integrate that into the code. And basically, you just edit one file in the Arduino IDE and add in your setup code and add in your loop code. And then it integrates it. And once you do that, this new sensor telemetry actually gets included and transmitted over the air. And so you'll receive it in Fox Telem, or if you decode an APRS packet, your new sensor data will be included. So, and my students recently successfully did that in class. So, so that's a good improvement there. We're going to continue supporting the version 1 hardware and maintaining the software for that. But going forward, we are going to be moving from beta and moving forward with this new hardware. So one of the big things I'm announcing this week here at Hamvention is a limited availability of kits. And kits has been something that people asked for quite a while. And there's two ways you can think about kits. One is a kit of parts, where we give you a bag with, here's all the things you've got to solder, go at it. Kind of like what I do for my students, where I give them a pile of parts and a board and a soldering iron and say, here, put it all together. But the way we've gone with this actually is we actually got the boards fully assembled. And so the kit part of it is you need to put it all together. So you have to stack it, you have to connect everything up. So I'll show you the kit here. So here is the kit. So we have the instructions with it. It comes with the 3D printed frame parts here. And then each of the individual boards is fully assembled. The software is programmed in the Pico and in the Raspberry Pi. The battery board comes with everything installed. And the solar board, we had these boards done mostly with surface mount to keep the costs down. And actually the cost of doing these with PCBWay is really quite amazing. Now, there is a small amount of soldering to be done. The solar panels, here, you do need to solder the jumper wires onto them. So you need to do that. In addition, there are two sensors that you need to solder the pin headers on. So there's probably about 20 minutes of soldering involved. Otherwise, the rest of the time you're putting it together. And so, for example, there's a bag of hardware here with screws, antenna, coax, and things like that. So we brought a number of these kits here to Hamvention, and we've actually sold all of them. But I will be putting some more on the AMSAT store in June. So if you're interested, I do have this one here in the booth, or you can come up and see me afterwards here to get a look at it. And if you're interested in picking up one of the ones that will go on the AMSAT store, it will be announced on AMSAT social media and AMSAT news service as well as to when that is, because probably they won't be up on the store very long. I'll probably do another run of them later in the year. But I don't know when exactly. So, okay. So I've talked a little bit about the individual boards already. So I will skip through these. And I already talked about the ground station. As I say, I really do recommend the Raspberry Pi ground station. And if you put a touch screen on it with speakers, it turns into a really nice radio appliance. Which you can use for other things too. And in fact, once you've the software that you use for receiving the slow scan TV images, if you connect it to an outside antenna, you could use that to receive the images from the ISS when they do that program every couple of months. So it's good for that. And here are the 5 different telemetry modes that the CubeSat simulator does. And normally, when going between the modes, there is a push button on the simulator and a little LED that blinks. And when I do my demos, that's how I usually change modes. So, time for the demo here. So I'm going to launch the simulator here by taking out the remove before flight. So it takes about 30 seconds or so for it to boot up. And the first thing we will hear is the CWID. Just get some audio going here. We'll hear that. Now, this is the one that I've been showing off in the booth, so it doesn't have solar panels on all sides. Also, this has the tape measure antenna, right? Which, of course, is a classic with CubeSats. There we go. Okay, so that was the CWID. And it's initially coming up in phase shift keying mode, which is the telemetry mode that Fox 1E used for its telemetry, and is also the mode that the Golf CubeSats that Jerry mentioned are going to use. And so it's a 1200 bit per second digital telemetry, and it has that lovely rumbling sound. Okay, so there it is there. So normally I would use the push button, but I'm going to try transmitting here, and we'll see. And when you do the push button, the green LED there blinks to tell you which mode it is. So if this works, that should blink when I transmit here. Let's see if it does. There we go. You see the blinks? Demos work. Amazing. Oh, except my radio just ran out of battery. Demos never work. It's proof. So it's currently rebooting now, and when it reboots, it will come up in slow scan TV mode, and we'll, assuming my radio recovers here, we will hear it. And the way the command and control, right now it's like the most basic command and control. It's just detecting a carrier at the frequency, and when it detects the carrier, it just goes to the next mode. So it cycles through the 5 modes that way. It's really just a proof of concept of the command and control, and we'll be able to add more advanced and more interesting things in the future. Okay, let's see if... Nope, it's totally dead. Okay. Well, you'll have to trust me, it's in slow scan TV mode, unless somebody has a radio and is listening to 434.9 megahertz, in which case you can hear the lovely tones of slow scan TV. Yeah? Oh, okay. Okay. Maybe the demo will be saved. 434.9 megahertz. And the fact yeah. There we go. Slow scan TV. This is Scotty 2 format. It basically snaps a photo with the camera and then transmits it. So okay, so command and control work. Thank you for the loan of the battery here. Don't let me walk off with it. Okay, so if you want to get involved with the CubeSat simulator program, there's a number of different ways. Even if you're not interested in purchasing one or building one, we have loaners. So if you'd like to take it into a school or into a club or something like that and do a public demonstration here in the U.S., just get in touch with me and we will make arrangements. I will ship you a loaner. So it will consist of a fully built CubeSat sim, and also the turntable, the LED lamp, and also the Raspberry Pi ground station with a touch screen. So everything you need really just to set it up, turn it on, and do demos of the various modes. We also provide some instructions and suggestions for what to do. So you can have it for a month or so, and then you just ship it back to me. So please get in touch with me if you want to do that. You can also build them too if you like to do soldering and 3D printing. It is a fun project for that. And as I say, we do have some limited availability of these put it together kits. Okay, so I guess we can take a couple questions here as we switch over here. And I just want to acknowledge the previous work that's gone on for the CubeSat simulator.